All right, good afternoon, everyone. Hope you had a good lunch break. My name is Renee from AIII and Hashtags. Welcome back. All right, so in the next segment, we'll be having our second panel on the future applications of AI in industry. Now, AI is rapidly shaping how business is being carried out and how revenues are being generated. Businesses large and small across the world are seeking to apply AI. While the promise of positive effects for businesses is undeniable, so too exists a tremendous amount of hype. Join us as we explore how businesses in various industries are harnessing AI in real and practical ways, what pitfalls to avoid, and how best to execute on AI strategies. May I now invite our fellow panelists, as well as our moderator. We'd like to invite our moderator, Sachin Chituru, partner of McKinsey & Company. Let's give him a round of applause. As well as fellow panelists, Girish Dilap Patil, Head of Technology, Gen AI and Digital Native Amazon Web Services for ASEAN. Dr. Gabriel Noje, Business Development for High Performance Computing, Asia Pacific, NVIDIA. And also Rajiv Hasamal, Gen AI Program Director, G-Star from DBS Bank.
Good afternoon, everyone. I think thanks a lot. I think we have a tall task of exciting all of you guys after a heavy lunch. And we hope we keep it light, interactive, and informative at the same time. Maybe I quickly introduce myself. I am Sachin. I'm a partner at McKinsey. I lead McKinsey's data analytics and digital services for all of Southeast Asia. We do a lot of work on large-scale data platform builds, AI analytics, and the likes. And we have a specialist unit called Quantum Black, which focuses on large-scale AI implementations. With me, we have very interesting, I would say, panel, which covers everybody from end users to hardware compute to service providers. So we should be getting some very interesting perspectives from across the board on the uses of AI and how it is set up. So I would just ask my fellow panelists to kind of introduce themselves quickly and kind of give us your sense or your view on how AI has shaped up over the last year. We have seen quite a bit of hype and discussions that have essentially happened in the last year after ChatGPT was launched. How has it been for you guys? What are the things that you are seeing? So maybe I hand it over to you first, Girish, and then you can talk about it.
Thanks, Raj. Thanks, Sachin. So yeah, I will quickly introduce myself. I have been in the industry for 20 years, been with Amazon for almost 10, worked on a lot of large-scale machine learning, distributed computing systems. In my current role, I am in a privileged position to be working with largest and some of the most innovative companies from this part of the world, as well as a lot of research labs, as well as universities. So with that intro, let me comment on what you asked, Sachin. So when the ChatGPT was launched, GPT-4 was launched, there was a lot of excitement. There was a lot of fear and anxiety as well. I would not say the anxiety has disappeared, but there was too much hype. And Gartner has this very nice mental model of Gartner hype cycle. I think we have passed the phase of hyper excitement and disillusionment. And people also now understand the limitations of the technology now. And they are working towards building productive applications. So this is like a slow growth curve, but it is of curve of launching a lot of productive applications in next 3 to 6 months.
Awesome, very good. How about you, Gabriel? How do you think about it?
Yeah, so I'm Gabriel Noja. I'm currently leading the business development for high-performance computing at NVIDIA Asia Pacific. I've been with NVIDIA for almost 6 years, and I've been doing HPC for the past 15 years. So back to your question, actually, AI is nothing new for NVIDIA. It's just that in the past maybe 1 year and a half, everyone wants to talk with NVIDIA about AI. But NVIDIA has been doing AI for the past couple of decades, actually. So if you go all the way back when we first launched the first programmable GPU, at that point in time, we were thinking, how can we accelerate other workloads on the GPUs, not just the graphics? And then in, I think, 2012, the first AI model, actually, convolutional model, there was a guy called Alex Krichevsky who ran ImageNet with the first deep neural network running on a GPU. So NVIDIA has been doing this for quite some time. I would say it wasn't necessarily something surprising for us. We've been working on this for many years. It's just that it really picked up, and really in each and every conversation that I'm having these days, everyone wants to talk about AI.
Very good. How about you, Rajiv? You commented from an end user and enterprise lens. So it would be good to interesting to get your views.
Hello, everyone. Rajiv from DBS. Last 8 years with DBS, driving large transformation programs over the last 8 years. Most recently, I took the Gen AI program director role, which is basically helping orchestrating all our activities within the bank to drive value from Gen AI. So that's my recent role. I echo my fellow panelists' comment that I don't think we're past the hype. I think from a DBS standpoint, we believe there's tremendous opportunities that can be unlocked by Gen AI. But we also see it similar to what Gabriel was saying. We've been doing AI for 10 years. Over the last 5 years, really doubled down on industrializing on AI. So we see it as an evolution. But as I'm sure we'll discuss a bit, we also need to be prudent. So finding the right balance is the key.
I think thanks a lot for these opening remarks. I think I'll just anchor on the point that Rajiv highlighted, and which I think you guys are also alluding to. So for us, when we start talking about AI, generative AI, a lot of the people in the field, this is not something new. This has been something that has been being executed, discussed upon in organizations, companies for the last 8 years, 9 years, etc. So now it's a good time because a lot of the large enterprises are really looking at this topic with renewed interest, right? In your view, as in case of Rajiv in your enterprise, in case of you, Gabriel, and Girish, in terms of how you are interacting with customers, what are your observations on how organizations are thinking about this new wave of use cases or AI capabilities? How are they thinking about implementing them? Are there any kind of learnings that they are taking from about 6-7 years of using and experimenting with AI? So maybe I hand it over to you, starting first.
Yeah. So I want to call out one thing though. So people have been working on AI for last 30-40 years. Like the first neural nets were trained in 60s. Efficient backpropagation algorithm was developed in 1980s. So there is a long history to the field, but there is a qualitative difference that we'll have to acknowledge, that people are going for larger and larger foundational models rather than training narrow or focused models. So in past, we used to train one model for every single use case. Now we are training like one model that can do 10,000 different tasks. That requires much larger compute, much larger RAM, and it's expensive, but it is exciting. The kind of abilities we have are unmatched compared to anything that we had before. But that said, there are also massive amount of challenges that are there, which is slowing down adoption. So I was speaking to you before this event, So in Southeast Asia, for example, right, Singapore is primarily an English-speaking country, but rest of the Southeast Asia has adoption of English to varying degrees. So there, for example, they don't find the models work just as well in their languages compared to how well they work in English. So there are a lot of challenges for regional languages. There are also challenges of cost, latency. There are also a lot of challenges because of regulators not being comfortable with serious organizations using models sitting out of the United States. So potential is huge, and this is a qualitatively different kind of approach to model building. But yeah, like all organizations are dug in. They are not giving up. They know this is the way to go. So yeah, exciting times.
So maybe with that, I want you to step in here, Rajiv, because the whole point in the end comes up to how are enterprises and organizations thinking about this. It's not like they haven't invested in AI. They have been investing for the last 8 years. And there is always a question on how much return am I getting from that investment. So how is an organization like yours thinking about this next wave of use cases?
So undoubtedly, there's tremendous value. But how do we go about it? The way we're looking at about it, first of all, from a solutioning standpoint, we want to be open architecture, agile and flexible. We're not putting all our bets into one solution. We want to make sure that the landscape is moving so fast that we don't know which will be the best model in 6 months, which will be the best provider in the next 1 year with the best capabilities. So we're making sure that we are agile in terms of our solutioning. So that's number one. In terms of use cases, so we spent most of the last 12 months experimenting on many different domains. Now what we're trying to do is for certain specific use cases which has the most value to really focus on them, industrialize them at scale, and try to drive value. So that will be our focus for the next year. Value can be in different ways: reducing employee toil, improving customer experience, driving productivity, entering new segments, new markets. So we are a bit focused for now more on immediate potential gain, reducing toil, and driving productivity. So that's our first step in the way we are moving forward. We also want to get our employees used to AI, not be fearful about AI. How do we communicate and manage the transition, make sure they understand the power of AI and how Gen AI will help them in their day-to-day lives. So that's how we're looking at it before we move to more complex use cases. As Girish mentioned, there's also some technological challenges when you want to be more customer-facing, latency, and also if you want to have a Gen AI to customer interaction, we still need to crack a few milestones. And as a bank, another key criteria is security. So we can't allow ourselves to fail on that front. So that's why we are experimenting on many domains and trying to industrialize on specific use cases and learn about it as we go along and build frameworks around it.
Very clear, very helpful. Gabriel, just to kind of come to you, I think as an organization, obviously, you are at the core of this founding infrastructure. If you think about the things that you're seeing getting enabled now in terms of large-scale text models, a huge amount of use cases on top of compute infrastructure, etc. We see that there is obviously a huge amount of innovation that is also going to happen when new capabilities come into play, like image, video, multimodal, etc. How is the compute infrastructure that Girish spoke about, which is essentially your domain, going to keep pace with these capabilities? And what are you seeing on the horizon?
Yeah. First of all, I wanted to go back to one of the points that both Girish and Rajiv mentioned. We've seen what our CEO called, and I'm going to steal your phrase, the iPhone moment of AI with ChatGPT. But ChatGPT is just text. Gen AI is a lot more than ChatGPT. There are so many ways in which you can use Gen AI in order to input the data, and it can be any type of data. It can be text, it can be image, it can be videos, it can be sound, and then generate knowledge, any type of knowledge. Again, it can be text, it can be image, it can be video. So I think the enterprises are still trying to grasp the extent of how Gen AI can change their business. And that's where we are trying to help, and not just from the infrastructure point of view. Again, a lot of people still think that NVIDIA is a chip manufacturer. In reality, I just wanted to let you know that more than half of our engineers are actually software engineers, not hardware engineers. So we are investing in a full stack. And again, to your point, we are trying to reduce that friction and not just putting new chips on the market which are better, faster, powerful to solve and to train the, for example, large language models, but we are trying to build an entire software stack from the drivers, the compilers, the libraries, the frameworks, the workflows, everything that comes into place, all the way up to maybe the last bit, which we'll leave it to others to do the actual implementation. But we are trying to build the entire software stack that comes on top of the hardware. And then the other thing that we are doing, we no longer focus just at the chip level. We are seeing the infrastructure from a data perspective view. We now have not just GPUs, we have CPU that we announced a while ago. We have DPUs, data processing units, and we are integrating everything together at the data center level. And obviously we are innovating. Again, we've been following the large language models trend, and which are basically based on transformer models for quite some time. And the GPU that we released about 2 years ago already had components at the architectural level that accelerated transformer models way before ChatGPT was even a thing. And that's actually made possible ChatGPT to come to the market. So I think we have a pretty visionary CEO, and we have a strong R&D team that is way ahead of the curve, and we're already looking 2-3 generations ahead in terms of hardware and software that we need to put together to answer all the questions from the developers and from the enterprises who are looking to build the infrastructure to support this.
This is extremely exciting, because now if I have to hear or kind of look at everything that you said, right? It looks like NVIDIA is going for a full stack solution. Right. So that's interesting. AWS is creating an optimized hosting environment for different elements, and over and above on top of the services infrastructure and all that stuff. That there. And enterprises are saying that we need a lot more control on the applications we actually put in our kind of footprint. If I think about this, there's obviously a lot of additional stakeholders also who are innovating on research, academia, and there is a lot of work that's happening in terms of advancing innovation. Would be good to get each of your thoughts on how this application provider landscape is going to change over the next 3-4 years. Because I see everybody trying to make a play on the space, and we want to understand how you think it will evolve. So maybe we hand it over to you guys to kind of talk about it from different kind of lenses.
Yeah. So in AWS, we have this belief that LLMs make everything better. Okay. So you are going to see this technology integrated with so many other technologies that one wouldn't have imagined. So for example, if you're firing a query on database, every time you have to know the database schema, figure out the right SQL statement to write, and then only you fire a SQL, right? How nice it would be if the model that is there knows about your database structure and what you want in form of data. You just describe in English. The system automatically figures out the SQL query and fires on the database, right? So LLMs can be integrated with so many other technologies. LLMs can be integrated, say for example, with simple transcription systems, voice transcription systems that are so prone to error. LLMs can help to eliminate those errors. LLMs are being used by some of our customers with their robots to power the understanding of the world around the robot in form of vision language models. So we see that at AWS, LLMs will probably be integrated with most of the services in some form or the other. And we see our customers, partners also integrating LLMs in their products. So yeah, this is going to be an all-pervasive technology. And as Gabriel said, LLMs are not the only type of foundational models. There are vision, voice, robotic foundational models. So we do see development in those areas as well. But right now, like 90% of the focus for most people is LLMs. Yeah.
Yeah, so I concur with what Giri said. So LLMs is basically large language models are the foundation. But I need to make you think a little bit different about LLMs. So natural language is, when we communicate, is the easiest way to interact with each other. It seems to be the easiest way to interact with computers and to either pass or obtain information. But think about other ways in which or applications that can be modeled as a language model. And just to give you an example, where we've been doing a lot of work at NVIDIA, healthcare, and in particular genomics, that ultimately is a language model. It's a very simple one. You only have 4 letters, alphabet, but in itself, it's a very complicated language model. So what we are doing is, for example, and we've seen a lot of partners and a lot of companies in the healthcare space where they use LLMs in the area of bioinformatics, for example. So the point being is, again, we are seeing LLM everywhere, and Gen AI, where basically there are startups every day which are developing new solutions based on large language models. We actually have our own program called NVIDIA Inception, where we are kind of tracking, or we are trying to track all the work that is being done in this field. And I see that a lot of big players are kind of playing catch-up game right now. The smaller startups are a lot more agile, and they're willing to develop and adapt much faster and follow. This is a fast changing field. Every week there's a new discovery, there's a new model, there's a new paper that is being published, and startups tend to follow that closer and be more agile in transforming and coming up with solutions faster. So I think the whole landscape is really changing.
Application of LLM. I think if you look at it from an innovation standpoint, and when I look at DBS, we were discussing last week, was for the first time, normally for innovation, you need to light fires across the bank to get ideas to bloom. For the first time, we have to put water on the fire because there's so many ideas, and we have to cool everyone down so that we can focus on building the capabilities, driving value, learn about it, and build up from there. So I have no doubt that the use cases that we are thinking today, in 6 months, there'll be another leap of ideas that will come in. But I think the key point is we need to learn how to use it, get our people learn how to use it before we expand too fast. Because other than the technological challenges, I would say, like stability, latency, that I have no doubt this will be solved in the next, it's a matter of weeks, months, rather than years. The people need to be brought along. So we have so many ideas, avatars, speaking to customers, and I won't divulge all the secrets here, but there are too many ideas. I think I have no doubt the next 3 years are going to be amazing, and lots of creativity.
I think that's quite interesting. I think maybe I'll try to push you guys a little bit here, right? I think the key question is, this is one of the areas in which we see huge amount of activity on open source as well, right? Huge amount of activity on open source. So there is enterprises who are saying that, hey, I don't need to lock myself up into kind of large scale closed ecosystem solutions. I can take open source and kind of develop custom tailored solutions for myself. There are large, I would say, obviously ecosystems, closed ecosystems like OpenAI, etc. There is also these niche apps that I think you were talking about, Gabriel, as well, right? How many of these are going to survive, to be very honest? Because a lot of the discussions that we are having with enterprises, just looking at the amount of risk that is there, they would like to control. They'd like a lot more control on the core elements of the LLM. Which ones are they using? How are they using it? So how do you guys think about that? Maybe Gabriel, you can elaborate a bit because you spoke about the application landscape also. But what is your view? How many of those applications are going to survive?
Even before, so the open source landscape has been thriving. It's going to be the same in the era of Gen AI. Open source is not going to die. From the enterprise perspective, again, it's up to their appetite if they want to have full view of what's happening inside, or they just want a black box that simply works. Then there's the question of sovereignty. Do they want to have full control of the data? Do they want to have complete control of what's happening inside? Or they again, they're willing to go with something proprietary. The other thing to keep in mind is that open source doesn't mean no support. Also, that's actually the model that NVIDIA has been following for all the software stack that we're building for our GPUs. We're pretty much open sourcing everything that we are building in NVIDIA. And then we provide commercial support if that is needed. If you have developers that are willing to use what we are developing and putting up in the open source space, then it's very good. They can continue to do that. So I think both will continue. I don't think that one will supersede the other.
Any comments, Girish? I think you had some open source related to it.
Yeah. So, these large language models are autoregressive. Do you know what is autoregressive? I assume you would, but let me still describe. So, when you see a 100-word reply by any chat system, okay, only one token comes, let us say word, only one word comes out of the model at a time. It is fed back into the model. Then the next word comes. Then the next word comes. And for every single word, there are hundreds of billions of calculations. Okay? If the model has trillion parameters, there are trillions of calculations for every single word. So the largest models are also very expensive to host and also very power intensive to run. Okay? So that's why we are not only going to have a trillion parameter model that are built by OpenAI or Amazon or Anthropic or whoever, but there is also going to be a range of smaller models. And who is building them? It's the open source community. And the results are impressive. They do have some rough edges, but they also meet the cost requirements, latency requirements, privacy requirements. Hence, organizations are willing to put up with them. So yeah, it's a thriving domain.
Very good. Rajiv, any comments on this?
I was fully aligned with what you just said, Girish. The way we look at it, depending on the use case, different LLMs will provide different types of value. The closed source, extremely large language model provide higher quality, but at a higher cost. But also all those large models, what we are seeing for the moment, every 2-3 weeks there's a new release. So if you go into production and you use the API and one day you get one answer, the next day you get that slightly different answer, that's a problem of control that from a bank perspective, we haven't cracked. So we are thinking about it. That's something we are looking at. So VS and open source, which is smaller, cheaper, as I mentioned before, value is important. So the cost of using LLMs is a key criteria. So we believe there will be domains which are very specific. So be it for legal perspective, which is very narrow type of use cases. You don't need an extremely large language model to leverage on that. So we believe that both will have a value going forward, and in an enterprise like DBS, we'll have a marketplace of LLMs for different types of use cases.
I think great. Just if I think about the points that you guys raised, obviously a key element that jumps out for me is control. on how you are able to control these applications, how you're able to control these models and so on. In fact, I was looking through all the questions which we are also getting on Slido. The questions that, at least 4 or 5 questions that have come up is, how do you bring more confidence amongst the boardroom that this is a technology that we have full control over? How do you drive adoption of this technology in the front line, ensuring that there are correct guardrails implemented on top of this technology? And the last bit is, how do you think about the kind of risk footprint that this technology actually exposes you, right? And so how are each of your customers, your own organization, thinking about this, and any advice that you would have for the participants here, right? So maybe I'll ask Girish, you to talk through first from a different kind of customer's lens, and then hand it over.
Yeah. So, yeah, of course, this technology is probabilistic. Okay. So when you get an answer from a chat system, what it is predicting is what word would come after the previous words. Okay. So what ends up happening is, many a times the answers that you get from these systems, they are right. Okay. But in rare situations, and some people would say it is not too rare, okay, you might get answers that are extremely logical sounding, they are extremely convincing, but they are incorrect. So this is known as hallucination, and this is a big problem. And this cannot be fixed by training larger models or curating better data, because that is how these models work, and there is going to be some amount of hallucination that is always going to happen. So that's why you need to couple these models with real world knowledge management systems that Rajiv and I were speaking of earlier. So this pattern is called as RAG, Retrieval Augmented Generation. I won't go in much detail of that. You can look for it on the internet. But this approach ensures that the answers that the model gives, they are accurate and reliable. So do not use models as a source of knowledge. Use the models as a source of wisdom or intelligence. Okay, and these are two different things. The second thing is jailbreaking. So jailbreaking is when people get models to do things that are harmful or disrespectful or stupid, for lack of better word. Jailbreaking is another problem that cannot be 100% fixed with current generation of technology. That's why there are firewalls coming to be put around models, and these are different from network firewalls, of course. And NVIDIA has a great project called as Nemo Guardrails. It's an open source one. You should explore that. And last but not least, don't use these models for things that they are not meant for. Okay. So if you ask a calculator to add 2 plus 2, it will give you an answer 4 in one shot. Okay. If you ask these 100 billion parameters model what is 2 plus 2, they will do like hundreds of billions of calculation to tell you the answer is 4, and sometimes they will get the answer that is wrong. Okay, so that's why you need to couple these models with external web services that can compute results in a reliable manner through an approach called as function calling. So in summary, don't use these models for what they are not meant for, which is precise computation. Be watchful of jailbreaking and use some technologies that are available that reduce the probability of jailbreaking, and always couple these models with real world knowledge sources. Don't use them as a source of facts. Use them as a source of wisdom and intelligence.
Rajiv, you will talk about some controls as you were elaborating very effectively on.
On DBS side, there are different angles to risk. So if hallucination, toxicity, how do you mitigate those risks to make sure that the output is, even though it looks correct, make sure it is actually correct. Even I think one of the constraint is, even if it's not correct, how do you ensure it's not harmful? So because by default, the models can generate answers which are incorrect or not 100% correct. How do you ensure it's not harmful? we also look at it from an end customer perspective. They will be facing phishing attacks leveraging LLMs, which is very difficult for an organization like us to prevent. So how do we educate the customers? How do we make sure the 1, 2, 3, 4, 5 factor authentication? So we need to think of how to review authentication for transactions and all. So from a customer standpoint. Then there's another angle of risk, which is the fear of our people, because GenAI drives fear. So how do we educate them along the way? How is going to help them along the way? So there are different ways of looking at risks, not only from an LLM perspective, but the risk that's generated around all these new technologies. So that's the way we're looking at it. We haven't cracked it, but that's one of my roles, to really focus on this and make sure we mitigate all the risks.
Great. Any comments from you, Gabriel, on this? Because I'm sure you must be thinking about the risks of technology as well.
Yeah, so I think actually Girish already mentioned, we are taking a very programmatical approach to this. We are developing solutions, software solutions mostly, to try to keep this LLMs in checks. And one of the projects that Girish mentioned, guardrails, was one of the projects that we put together very early after ChatGPT was launched. We had that idea in mind for quite some time on what's happening when this large language model starts to hallucinate, and as they get bigger and bigger and bigger, you start to see more and more of this problem, especially if they're not connected to a database where it can actually get factual information. So we put together this project at the beginning of this year. So now we have a fairly mature software solution that is part of our framework for large language models. And the other thing Girish already mentioned, and again, in our core products, in our core SDK for large language models, we from the beginning we looked at the idea of linking the large language model with the source of truth and trying to build explainability into the AI. So you've seen that there are now models that when you're asking a question, they can actually provide references where they actually get that answer. So we're starting to, we are looking more and more, we started actually a while ago, to look into explainable AI and how to bring confidence that the answer that the large language model is providing is actually the correct answer.
Very good. I think I'm now seeing the questions coming in, and there is a huge amount of interest in understanding the applications. And when I say applications, the question is, apart from everything that we have heard about text and GPT, what is the next big leap in terms of applications that you guys are excited about personally?
Okay. So if you look at it, most of the language models, commercial ones, for example, the way you access is the way you access any other API, right? You call the API, you send some input, and you get an output. So that part is not that different compared to how people have been developing software. But now what we are going to have is a dynamic software, which will not execute a set of predefined action, but it will dynamically figure out what are the set of actions that it should take, okay, depending on the situation, depending on the context. So there is this concept called as autonomous agents, okay. You must have seen projects like AutoGPT and Baby AGI and all that. Those started as fun projects. They became rapidly popular. I think AutoGPT got like 100,000 likes or stars on GitHub in a single month, which is something that has never happened. So this is a new paradigm of software development where the software figures out dynamically with help of a LLM what actions it should take, and then it performs those actions. Again, this is not a foolproof approach. It has its pitfalls, but it is growing rapidly because it is the way to go. Say, for example, if you want to do a market research on something, right? That larger task can be broken into smaller tasks. Then you can contact internet, you can get information, you can look at that information and then decide again whether you are ready to prepare a report or you need to search more. So this is like a multi-step action. So these can be automated with autonomous agent framework. As a caveat, this is not a foolproof approach. It has its pitfalls, but nonetheless, it's a very powerful approach. So at Amazon, we are trying to figure out how do we make such approaches accessible to large-scale customers. So few months back, we launched this service, or rather a feature for an existing service called as Bedrock Agents that makes it easy to have this kind of a dynamic software. So this is probably the biggest paradigm shift to the software development that I have seen in like probably last 10 or 20 years.
Good. How about you, Rajiv?
So we're getting outside my comfort zone. It's more technical. My two friends here,
Okay,
I'm sure, have more things to say. But to your point, Girish, on software lifecycle, so that's, again, one of the domains we're looking into. So far, sorry, I'm taking audience role now, we haven't seen anyone that have cracked leveraging GenAI to write code at scale. We all read articles between 10%, 30, 50% value generated when you're in a sandbox or experiment mode. But when you expand it to 1,000, 5,000, 100,000, it's not like you're gonna save. So we haven't seen that. So how do you see this change going forward?
It's a very, very good question, Raju. Thanks for asking it on behalf of audience. So when Copilot came, right, and it was a very innovative product, software developers thought that they are going to lose their jobs because it makes code generation so easy, right? You don't have to go to Stack Overflow or Google for the syntax. Everything gets created rapidly for you, right? And that anxiety happened because you fundamentally misunderstand the role of a software developer. Role of the software developer is not to type in a syntax in a code editor. The role of a software developer is to actually understand what are the requirements and how do I best meet these requirements? What are the trade-offs? Because many a times you cannot achieve ideal outcome, right? So you always have to go for the trade-off. And trade-off can only be done by talking to business people and talking to other people, right? So there are so many things that a software engineer needs to do to be a successful software engineer that these models can't do. So probably the only improvement in the workflow is probably 5% in that initial stages. But that said, I am extremely excited about this technology because, see, DBS is such a reputable organization. They attract the best talent in the industry. So is Amazon, so is NVIDIA, right? The engineers who join here, they are already very good. That's why they are here. But then there are so many engineers in developing world who haven't got the best of the training, so on and so forth. So for them, this technology can help them get started very fast. It can provide a boilerplate code that will probably be 30%, 40% ready, and they can iterate on that code and then get past the final hurdle, right? So getting started is important. So there is this saying, right? Well begun is half done, and that is true for software development as well. And I'm guessing probably these Copilot and all are not going to kill software development as a profession, but probably we are going to have 1 billion people developing software because it is going to be so easy to start, and we are going to have a lot of creative applications. But probably DBS, Amazon, and NVIDIA wouldn't see as big an impact. Yeah.
Good. Gabriel, I'll come to you with a bit of a tangential question, right? Obviously, there is a lot of debate around how sustainable is this technology, and how do you think about energy consumption? How do you think about usage? And what do you think about the footprint of this technology on all the climate goals as well? What is the view from your organization, and how are you thinking about the impact, and how are you adjusting for it?
Yeah, so it's a very good question. And when we're talking about larger and larger models that need to be trained, that obviously requires larger and larger infrastructure. And there are two directions here. First of all, as Giri said, you might not necessarily need such a large model. There are new research being done on how to optimize those models, how to make them better, more efficient, so that you don't have to spend a lot of hardware infrastructure to train them. Then from the infrastructure itself, NVIDIA was always looking at how to improve the ROI and the energy efficiency of our chips. And we were talking earlier before we started the panel. Again, our CEO has a saying: the more you buy, the more you save. And what he means by that is that if you have in order to achieve the exact same result for a specific workload, if you're changing to a GPU accelerated infrastructure, you're actually needing a lot less infrastructure, and you're consuming a lot less power, energy. Cost obviously is going down. Even so this is at the macro level, at the data center level. If you go all the way down to the chip level, we are doing all sorts of innovation to make sure that the new chips, the new algorithms that we are developing at the very low level, those are improving the energy consumption for our chips. So it's a multi-pronged approach that NVIDIA is doing without going into very technical details. But the overall idea is that we are trying to make our solutions as energy efficient as possible. And the other thing to keep in mind is that everyone is talking about training, but inference will actually require even more infrastructure. So we are actually looking at how to make the inferencing infrastructure more energy efficient. And again, we're doing multiple innovations in how to approach that. And definitely, overall energy efficiency is at the core of everything that NVIDIA is doing.
Very good. Maybe Girish, how is AWS thinking about this energy thing?
Yes, so energy is probably the biggest hurdle. Semiconductor supply and best-in-class chips is still another one. But as I said, these models are extremely energy hungry. They have a huge carbon footprint. So in early days, we started with the largest possible model because we wanted something that worked for sure. But now we are able to make trade-off by selecting smaller models that are appropriate for a certain kind of use case. And we have seen models as small as 1 billion parameter models. Okay. Now 1 billion to begin with may sound a lot, but the leading edge models have trillions of more than 1 trillion parameters. Okay. So this is like 0.1% of the size of the state of the art model, right? So we have seen 1 billion parameter model on specific tasks. They can beat 1,000 times bigger model in terms of quality. Okay. So now people are realizing is for everything they don't have to use the state of the art most complex model that probably cannot provide high throughput, but they can go for specially tuned models. So on AWS, there is this marketplace called as SageMaker Jumpstart, where you can discover large number of models which are both commercial as well as open source. They can be fine-tuned for a specific situation. It will be much cheaper because they require much lesser RAM, and of course they require lesser power. So this is the key if we want to see LLMs integrated in most of the applications. Otherwise, if you are going to use a trillion parameter model, there are limitations on how much they can scale for throughput as well as latency.
Great. I think we come to the end of the session, so I'll just ask for closing remarks from my panelists. And I think the question I would like to pose is, I was looking at the chat, there is a question around young professionals coming into the workforce. Now, the question is around how should they prepare themselves for how the future is going to shape up. What are the skill sets that they should be picking up? How are you guys thinking about talent? And how can they slot in? So maybe I'll ask Rajiv first to comment on this because talent is an important part for enterprise scalability and sustainability.
So, over the last few weeks, I've been getting lots of coffee requests, attending town halls to present about Gen AI. It's the hottest topic that's being discussed for now in the HR town hall. One of the points was use it. Once you use it, you'll understand the power. Once you understand the power, you will create new ideas. Once we create new ideas, there'll be new opportunities. So I can't tell you today exactly what's the skill set. I have a 3-year-old, so I have a very young kid. I can't say today what's the skill he should work towards for because we don't know what's going to be. 20 years ago, I don't think we would have talked about data analysts. We don't know what the next 20 years will bring, but embrace it because it's so powerful. It will drive creativity, new ideas. So use it. So that would be my advice.
How about you, Gabriel?
NVIDIA, again, since we've been working on this for a long time, we actually put together ourselves a range of programs to reach out to the young generation, to the youths. We are having partnership with high schools, with universities. We have our own training programs called the Deep Learning Institute, where we are providing courses. I've been teaching a lot of courses about GPU programming, AI, myself here in the region and worldwide. So the way we see is pretty much as you said, we want the young generation to embrace this. We want them to understand not necessarily all the ins and outs of how Gen AI works or how AI works, but to understand how to use it and how to make use of it. And if they want to go deeper, obviously we can we have programs through which they can go deeper. The other thing is working with the higher education and research institutes to make sure that this becomes part of the curriculum. And NVIDIA has had all sorts of partnerships, both here in Singapore as well as in the region and worldwide, where we are trying to make a push to adopt these new technologies as part of the curriculum, so that the young generation learns from a very young age. In the past, when I was in high school, I started to learn about programming in Pascal and C. For those of you who are old enough, might know what that is. But the new generation might not even need to know that. So they need to learn about the power of AI and how to use it to their advantage.
Girish, your thoughts?
Yeah. So there are different layers, right? So even if you are a normal, regular programmer, right, you should not think that this technology is only for data scientists or AI engineers, because these are foundational models. They are very easy to configure and use. And one of the ways you get them to work for you is by prompting them in a specific way. Okay? So don't think that this task is for AI engineers or data scientists, right? There are other people who will take specific interest in training and performance optimization and all, but probably 99% of the people can still create a lot of value for their companies just if they figure out how to use these models or their API. So that's one thing. The second thing that I wanted to say is probably we don't know what are the things that are going to be important in next 5 or 10 years, because this technology is surprising us every next week with the new technologies it is or skills it is mastering. But probably what we need to train ourselves is we need to train our learning muscles. Okay, so there is this concept called as learning to learn. So we need to keep learning continuously so that our muscles don't get lost and we are able to pick up new skills all the time. That's the only way to be ready for the future. I don't know any other way because there is no specific answer.
Okay, I think great thoughts. I think we're over time, but I hope you guys kind of listen to a range of opinions on a range of topics. The technology that we are talking about here is very new. There is a lot of people across the board who are coming to terms with it, figuring out how to control it, how to influence it, how to make use of it in the most efficient way possible. And as Girish kind of summed it in the end, I think this is going to be a big learning journey for all of us. And that's what we are doing it on our teams. That's what we are encouraging our customers and clients to do. And that's what we think we would advise everybody else to do as well. Thank you. Thank you for having us.
Thank you.
I hope you found
Thank you.
Thank you.
Round of applause to our panelists. Please come forward for a photo taking session without your badges. Yeah. Thank you. Come forward. Yes, the front of the stage. All right, we still have our next session, so do stay.